energy must be transferred to a system to cause a substance to melt or boil. So here we represent the different phases of a substance using a heating curve, so solid, liquid and gas. And we'll look at H2O in those three phases as an example. So as heat is added, there's an increase in temperature because the molecules gain kinetic energy up to the melting point where a phase change occurs. And during a phase change, the temperature is constant because there's no increase in kinetic energy of the molecules. And the heat that's input, being the heat of fusion, is used to overcome the intermolecular forces between the molecules. And as heat continues to be added, the kinetic energy of the molecules increases until the phase change from a liquid to a gas, being vaporization, where the heat input is equal to the enthalpy of vaporization. So as you can see, this is longer than the melting phase because it's harder to break apart water molecules because they're surrounded by more molecules and they're closer together compared to ice. Now going backwards, you have a decrease in energy because heat is flowing out of the system. And during the next phase change, being condensation, the enthalpy of condensation is equal to the negative of the enthalpy of vaporization. And the same thing as we keep going backwards until a phase change from a liquid to a solid, being freezing, where the enthalpy of freezing is the negative of the enthalpy of fusion. And you'll also notice a shallower slope, for example, in the liquid phase compared to the solid phase, because the specific heat of ice is smaller than the specific heat of water. Because you need to add more heat in the liquid phase to cause an increase in temperature compared to the solid phase. A 2.1 gram ice cube has an initial temperature of 10.3 degrees Celsius. How much heat is required to vaporize the ice completely if the melting point of ice is 0 degrees and the boiling point of water is 100 degrees? And we can use the following properties. So the heat required to increase the temperature of the ice to the melting point can be obtained using the heat transfer equation. We have 2.1 grams of ice and a specific heat of ice and a change in temperature. And now the heat required to change phase from a solid to a liquid is equal to the enthalpy of fusion multiplied by the number of moles of H2O, and we can convert this to a number of joules. And you can obtain a number of moles of H2O using the mass and the molar mass. And similarly, we can use the heat transfer equation to determine the heat required to increase the temperature of the water up to the boiling point. So using the specific heat of water, and a change in temperature from 0 to 100 degrees. And then we can use the enthalpy of vaporization to determine the heat required to change phase from a liquid to a gas. So similarly, using the number of moles of H2O and converting this to joules. And therefore the total heat required can be obtained by adding these together and using the correct number of significant figures.